So good evening everyone and welcome to today's lecture. This is lecture number 6 and we are supposed to do standing waves in this particular class and finish it as soon as possible. Let us first go into the previous class and see what we had seen. We had seen the two types of interference, constructive interference and destructive interference. Do we remember this constructive and destructive interference?
Yes, sir.
We had seen that for constructive interference, your phase difference should be an even multiple of pi, 2n pi. And when that happens, your amplitude is maximum and your intensity is also maximum. Yes or no?
Yes, sir.
We have seen for destructive interference, it should be an odd multiple of pi. The phi, the phase difference should be an odd multiple of pi. Do we remember this?
Yes, sir.
Now we talked about phase difference. We can also write the same thing in terms of path difference. How much should be the path difference? Here also we have written the same thing in terms of phase difference and path difference. Phase difference was 2n pi. Path difference was n lambda. What will be the path difference here? Can anyone tell me? For destructive interference. Yes.
2n plus 1 by 2 lambda, sir.
Think again. Try again. Something I think is missing. Try it again. 2n plus 1. 2n plus 1 by 2. Or what? Fast, fast, fast. It's a simple question. 2n plus 1 what? 2n plus 1 times lambda by 2 should be the path difference. Do we understand this? Yes or no? We understand this? That is what you said? Or you said something else? Yes?
Said that only, sir.
Okay, I thought that you had said 2n plus 1 by 2 lambda. 2n plus 1 by 2 lambda is wrong. 2n plus 1 into lambda by 2. That is what we must say. Everyone gets this, yes or no?
Yes, sir.
Okay. So we have seen interference, we have seen superposition, and we have seen that this superposition is nothing but we had already seen it in the chapter on simple harmonic motion. Yes or no?
Yes, sir.
Now, here we had seen some formulae of maximum intensity and minimum intensity. Yes or no? And we have seen that interference is nothing but redistribution of energy or intensity. Yes or no?
Yes, sir.
Now here also you can write one more formula. If I'll give you that formula, let me see if I have some space here or not. I have some space here, so I will write the formula here. Okay. Now, if you have two waves of same intensity with a phase difference of pi of phi, then the intensity of the superposition can be written as I naught squared. Let us say that the intensity of the wave is I naught of the two interfering wave is I naught. So you can write it as I naught plus 2 times I naught into cos phi. Do we remember this? The relation between intensity of the wave which is coming from the superposition. Do we remember this formula?
Yes, sir.
Intensity. Here, I had written it in this form. Intensity is I1, intensity of first wave plus intensity of the second wave plus 2 times root over I1, I2 cos phi. I have just taken a case where these intensities are same and I have written it as I naught. Do we understand this? Yes or no?
Yes, sir.
Now this formula can be squeezed and I can write the intensity, wrong color. This formula can be written in this legendary form. I will be equal to, how can I write it? Can I write it like this way? 4 I naught cos square. Why this is happening? Happened too many times today. So I can write the formula. I is equal to 4 I naught cos square phi by 2. Can I write it in this way? Using the double angle formula, yes or no?
Sir.
So remember this form of this intensity as well, where intensity of both the waves are same. You can write the formula in this fashion also. Okay. I hope we have understood this, yes or no?
Yes, sir.
Then I think I had given you this question. Two sinusoidal waves of same frequency are sent in the same direction along a taut spring. One wave has an amplitude of 5, other has an amplitude of 8, and you had to solve this question. Did you get the answers for this one? No? Did you try this question? No one tried it, so I will give you 2 minutes to.
They tried, but they did not get answer.
I'll give you 2 more minutes to do it. Try it now and tell me what you are not getting. 2 minutes you have. Yes, now tell me the answer.
A is pi,
See, you
B is
got the answer.
3.
See, you got the answer. A is pi. It has to
B
be
is 3.
it has to be odd multiple of pi.
Yes, sir.
So the first odd multiple is pi. So the
Uh-huh.
first answer is pi.
Pi. B is 3.
First answer is pi. Let me write it as pi. Then
B is 3.
B. What is the smallest amplitude? The smallest amplitude will be 5 minus 3. So the answer is 8 minus 5. So the smallest amplitude is 3. That's
3.
correct.
And C is 0.
Yes, C is 0. What is the odd even multiples of pi? First even multiple of pi is, you can say, 0, or it is 2 pi. So the
2.
answer for the third part becomes 0. That is correct.
C is 13. Sorry,
The
D
lar-
is 15.
yes, the largest amplitude is 8 plus 5, that is
Yes,
13.
sir.
Yes, that is correct. Yes.
And E is root 89.
E, when the phase difference, when the phase difference is your phi 1 minus phi 2 by 2, so pi minus 0, 90 degrees. So it will be root
Pi by
over 5 square plus root over a square. So the resultant amplitude in that case will be root over 25 plus root over 8 square, that is 64, and that
2.
is
Yes,
the
sir.
answer. See, it was so simple. There was no confusion at all. What was confusing you in this question? Tell me. What was the confusion? Tell me. What was the confusion that you could not understand? Tell me fast. Huh? Tell me fast. What was the confusion so that I can understand? No.
Sir, first I didn't know how to take that smallest amplitude. I didn't revise that.
That is the problem, na beta. You have to understand the problem. I understand the problem. That is the problem. If you don't read, the entire class for today will also go in waste. No. Don't remember what we had done in the previous class, because every class that we are going to do is related to the previous class. If you don't remember superposition and what was constructive and what was destructive interference, then the problem becomes tough. Do we understand this? Yes or no?
Yes, sir.
Okay. Chalo. Now we come to the next topic, because it is essential for us to move forward, and that is known as reflection and refraction of waves. Refraction and refraction of waves. So write the heading. Just, just give me 2 minutes, beta. I just have to go. Just give me 2 minutes.
Yes.
Okay. Reflection and refraction of waves. So now we are going to see how waves are getting reflected and refracted, or you can also call them transmitted. Now, now remember, when we are talking about these waves, this could be transverse wave, or this could be longitudinal waves. Now, when we do it in two different cases. If I talk about reflection of waves. Now, this reflection of this wave can be from a rigid or fixed end, or it could be from a denser medium. Now, what do I mean by this denser medium and this rigid or the fixed end? I will try to make it up. Now, the fixed end means the end cannot move. There is no motion of the end. Just first listen to me, then I'll give you time to write. So you have a string and it is attached on the other end by a knot, and then you create a wave in that string. So that end becomes a fixed end. That end cannot move. Do we understand this?
Yes, sir.
Now what you see here, if you have a crest going on to that fixed end, it will be reflected back as a trough. Do we understand this? A crest is getting reflected as a trough. So basically what is happening is it is undergoing a phase change of pi. Do we see this? Do we see that there is a phase change of pi?
Yes, sir.
There is a phase change of how much?
Pi. Sorry.
Phase change of pi whenever, please first understand this and then you will write this. So you can see the equation of the incident wave is y1 is equal to a sine omega t minus kx, whereas the reflected wave will be a sine omega t plus kx, because it is moving in the negative x-axis, plus pi So you can write it like this. Do we understand this? Yes or no? No or yes?
Yes, sir.
Okay. Now the same thing. Now the same thing will happen if we have a longitudinal wave or we have a wave getting reflected from a denser medium. For example, if the same wave, this was the wave, and at this point it was going into another medium, the material of this has changed. This was a rarer medium and this was a denser medium. So what happens is on this side you have a rarer medium, and on the other side you have a denser medium.
Denser medium.
Now what happens is this will not happen in case of your transverse wave. It will happen more for your longitudinal wave. So if a longitudinal wave, let us say a sound wave is going, and if a sound wave is going from a rarer medium to denser medium, the same thing will happen. Let us not draw it in diagram because it will become confusing, because we have not done sound waves till now. But if any wave is getting reflected from a fixed end, or any wave is going from rarer medium to denser medium and it is getting reflected, it will undergo a phase change of pi radians. You just have to remember this. Do we understand this?
Yes, sir.
Pakka?
Yes, sir.
I'll give you 2 minutes now to note it down. This was reflection from a fixed end. This is how a fixed end looks like. What would be the next case scenario? The next case scenario will be reflection from free end. Reflection from free end. Now what do I mean by reflection from a free end? A free end is an end that can if I can get a better diagram here. Here. Okay, this diagram would help. A reflected free end would be an end which is free to move. Now I'll try to show it with these two examples. Now, this is the example of a free end. For example, instead of tying this string to a rod or to that wall, I tie it to a ring, and that ring can move on a rod. Do you understand what I'm saying? This is a rod. If I tie the string directly to this rod, it becomes a fixed end.
Yes, sir.
But if I tie it to a ring, and if I put a ring on this rod and if I tie this to a ring, it becomes a free end because this can move. Do we understand this?
Yes, sir.
If it is reflected from a free end, we can also call free end as rarer medium. It does not undergo any phase change. No phase change occurs at the free end. So if your incident wave, if your incident wave is y is equal to a1 sine omega t minus kx, I hope you can see it on your screens. Your reflected wave will simply become y is equal to a sine omega t plus kx. The same thing happens when a wave is reflected from a denser medium to a rarer medium, when it goes from a denser to a rarer medium, I mean it is reflected from a rarer medium, there is no phase change. Crest is reflected back as a crest, and trough is reflected back as a trough. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. This was about reflection from a rigid end and reflection from a free end. Now we move on to refraction. Now refraction or transmission, refraction or transmission, refraction or transmission. Now, whether the refraction is happening from a rarer medium to denser medium, or it is happening from denser medium to rarer medium, there is no phase change. No phase change. There is no phase change, but the medium changes. Do we understand this? But the medium changes. Do we understand this? That implies the things which are related to the medium will change. What are the things that are related to the medium? V, velocity, lambda, and k. K is 2 pi by lambda. These three things will change. Do we understand this? Yes or no? No, yes. Do we understand this? Do we understand this?
Yes, sir.
Pakka?
Yes, sir.
Okay. Have you noted this down?
Done, sir.
Now, if we take reflection and refraction together and see this diagram, and here they have made incident wave traveling into a different medium. Remember, whenever we talk about reflection and refraction, no wave is completely reflected and no wave is completely refracted. Do we know this? Yes or no? Do we know this? Yes or no? Do we know this? Yes or no?
Yes, sir.
A part of it is reflected, a part of it is refracted. Do we understand this? Yes or no?
Yes, sir.
Now, whenever we have this reflection and refraction coming together, what all things change and what all things remain constant? And this is a very important thing that you must understand. First you write it, first you understand it, then you write it. The first thing is frequency. Remember, this frequency of the wave depends on the source. Yes or no? No, yes.
Yes, sir.
Will it change when the wave is reflected or when the wave is refracted?
No, sir.
That will not change. Why will it not change? Because it depends on the source. Unless you change the source, nothing changes. Yes or no?
Yes, sir.
Then you have seen this incident angle and this reflected angle and this transmitted angle or the angle of refraction. You know the relation between them. Yes or no?
Yes, sir.
This is reflection and refraction put together. The incident ray, the reflected ray, normal and refracted ray, all will lie in the same plane. Do we know this? Yes or no?
Yes, sir.
Okay. First, listen to me, then I will give you time to write. Then you must have also seen point number 3. I will give all the points in one. This angle of incidence is equal to the angle of refraction. Do we know this? Yes or no?
Yes, sir.
Then for angle of refraction, we have the Snell's law. Have you heard and remember the Snell's law?
Yes, sir.
Everyone remembers the Snell's law?
Yes, sir.
Sin I by sin R or sin I by sin T, because we are calling it the transmission. Sin I by sin T is Vi by Vt. That will
Yes,
be
sir.
equal to lambda I by lambda T. Do we Understand what I'm saying here?
Yes, sir.
Because frequency remains same. Yes or no? No or yes?
Yes, sir.
Okay. I cannot put anything more here. So what I will do is I'll give you 2 minutes to note this point down. Do not note it like this, two here, two there. Huh? I just done this because I wanted everything on one page. Okay. So note
Yes.
it down because these are very important points that we are discussing. I'll give you 2 minutes to note it down. Note it down aram se. So we have written these 2 points, I mean 4 points. Now we must understand that we also must see what will happen if the wave is getting reflected from a fixed end or whether the wave is getting reflected from a free end. Do we understand fixed end and free end?
Yes, sir.
What is fixed end? What is free end? Fixed end means denser medium, free end
Free
means
and free.
rarer medium. Do we understand this?
Yes, sir.
Now, what do we see here? If the reflection happens from a denser medium or rigid support, the phase changes by pi and direction will reverse because it is getting reflected. Yes or no?
Yes, sir.
What you have to note here is they have given the equation of the incident wave as A1 sine omega t minus kx. You understand this equation?
Yes, sir.
But they have given the reflected wave as AR, where AR is the amplitude of the reflected wave. Here what has happened, the entire wave is not getting reflected back. Some wave is getting reflected back and some wave is getting refracted, and therefore the amplitude of the reflected wave and the amplitude of the refracted wave will not be same. Do we understand this?
Yes, sir.
Therefore, they have written AR and AT. AR means amplitude of the reflected wave and AT means amplitude of the transmitted wave. Do we understand this?
Yes, sir.
Okay, one more point, then you can note down. If it is getting reflected from a free end, then will there be any phase change? Then there will not be any phase change. There will be only change in direction. Do we understand this?
Yes, sir.
So these are the 6 points that we have to remember. Again, remember, again see, if the wave is getting reflected from a rarer medium or a free end, phase does not change, but direction reverses.
Yes, sir.
The incident ray is given as A1, AI or A1, whatever you call it. But the reflected way is given as AR because why? Because it is not getting completely reflected. Some part of it is going in the other medium. Do we understand this?
Yes, sir.
2 minutes you have. Now this is a table where everything has been summarized, what changes, what does not change. Remember, frequency always remains constant. Do we understand
Yes,
this?
sir.
This is the concept of reflection of wave. What happens when wave are reflected? Remember what happens when wave are transmitted or refracted. Phase never changes, frequency never changes. The only thing that changes is the speed or the wavelength of the wave. Do we understand this, or this has gone above our head saying bye bye?
We understand, sir.
I'll give you 2 minutes to draw this table if you want to. Everything we have already discussed. This is just put in a tabular form. I think everything has been written ulta. Crest will be going as straw and straw will be going as crest, and this is crest will be going as crest and trough will be going as trough. So things were written ulta. Now correct? Typing mistake. Got this? Anything else? No, this entire table was wrong actually. I'll have to correct it. Okay, now we move on and we see, and that is a very important thing that we are going to do now, because you will not find it in most of the books that are there. and we'll see what will be the equations of these two waves, the reflected wave and the refracted wave. I'm going to show you. I'm going to show you a snapshot. Now this is the snapshot of a wave which is getting reflected from reflected as well as refracted from a denser medium. So the medium on the left hand side is a rarer medium, and the medium on the right hand side is a denser medium. So it is getting partly reflected and partly refracted. What we have to see is that and listen to this very carefully, do not make any mistake. This is the equation of the incident wave. Yi is equal to ai into sine omega t minus k1x. Do we understand this? I will write it here in bigger. Yi incident wave is ai sine of omega t minus k1x. Do we understand this?
Yes, sir.
The wave is getting reflected from a denser medium, and therefore it undergoes a phase change of pi. So the equation of the reflected wave, this is the equation of the incident wave. The equation of the reflected wave, can anyone tell me what will be the equation of the reflected wave? YR. YR will be equal to
AR sine omega
AR
t plus K1x
sine omega t plus k1x
plus
plus pi. Do we understand this?
yes, sir.
What you have to see here, that omega and omega are same. Why they are same? Because it depends on the
So
what? Omega depends on what?
medium source.
Yes, it depends on the source. K1 and K1 are same. Why they are same?
Because they depend on source. Sorry. They depend on medium.
It depends on medium. This pi has come. Why this pi has come?
Change in phase, sir.
Change in phase. Why this plus has come? Here it was minus. Why it is plus?
Direction, sir. Direction has changed.
Here it was AI. Here it was AR. Why not same?
Incident, it is reflected.
Because it is incident and the complete wave is not getting refracted,
Yes.
reflected. Do we understand this?
Yes, sir.
Chalo. Now we look at this equation, and I will write this equation in bigger. Once you understand this, then you
YT
write it on your own. YT, Y transmitted, will be equal to A transmitted
transmitted
sine of omega t minus K2x. Do we understand why K2 here? Why K2 here?
medium has changed.
Because the medium has changed. So this is what happens when waves are getting reflected and transmitted. Do we understand this?
Yes, sir.
From which medium? From rarer
Rarer to denser.
to denser. And I'll now give you 2 minutes to draw the diagram and understand it as it is, and try to write the equations on your own.
Yes.
This was reflection and refraction from a denser medium. Now you will have to write reflection and refraction from a rarer medium.
Uh,
Can you do it on your own?
Yes, sir.
Okay, this is the diagram that is there. Now it is getting reflected and refracted from denser to rarer. So you have to draw the diagram again from denser to rarer. You understand everything in this diagram?
Yes, sir.
I'll give you 2 minutes to draw this diagram. Well done. Then there are two unknowns here, as you can see in the diagram. This is AT and there is AR. There must be a relation between AT and AR. Yes or no?
Yes, sir.
The only thing that is known to you is the amplitude of the incident wave. Yes or no?
Yes, sir.
So everything should be known in terms of the amplitude of the incident wave. Yes or no?
Yes, sir.
And these are the two formulas that you will have to remember. The amplitude of the reflected wave is given by this legendary formula. Don't forget this. And the amplitude of the transmitted wave is given by this legendary formula. Now, V2 and V1. What are V2 and V1? V2 and V1. V2 is the speed of the wave in the second medium, which is the refracted medium, and V1 is the speed in the first medium. As you can see, in a rarer medium, when the medium is rarer, V2 will be more than V1. So it is going from denser to rarer. AR is positive. That means AR and AI are in the same direction and therefore there is no phase change. So from this equation, apart from getting the value of AR and AT, you will also see that the phase change will automatically come. Do we understand what I'm saying here?
Yes, sir.
If V1 is more than V2, that means I'm going from rarer to denser. AR will always become negative. Do we understand this? Yes or no?
Yes, sir.
I'll give you 2 minutes to note this down. Everyone has done this question now. Questions on this topic is pretty rare and they will only come in your JEE Advanced. This is one question, so we have to do it with utmost of sincerity, and this encompasses everything that we have done till now in this chapter. So now I present to you this question. If you can do this question, that means the entire topic up till now is covered. And here comes the question. A harmonic wave is traveling on string 1 at a junction with string 2. So this is a different string. It is partly reflected and partly transmitted. The linear mass density of the second string, so linear mass density is also coming, is 4 times that of the first string. And that the boundary between the two strings is at x is equal to 0. The expression of the incident wave is this. To find out the expression for the transmitted and reflected wave in terms of A1 or AI, K1 and omega 1. Have you understood the question? Yes or no? No or yes? So this question basically tests everything that we know from this transverse wave, and I'll give you 2 minutes, 3 minutes. Take your time. Go back to the formula if you want to. If you can do this question, that means we are good with this. I'll give you time, 5 minutes. Don't worry. Let me know once you are done. If you cannot do it, let me also know that.
Yes.
Okay, if you got nothing, then what should we do? I'll go on and solve this question. I must first find out the relation between the velocities. What is the velocity of the incident wave?
Omega 1 by K. Omega 1 by K1, sir.
Velocity of the incident wave, Vi, which is nothing but velocity will remain same in the incident medium. So velocity V1 will be equal to omega 1 by K1. Yes or no?
Yes, sir.
You have to find out the velocity in the second medium. How will I find the velocity in the second medium?
Not get that one.
Huh?
Did not get that one.
How will I find the velocity in the second medium? You wrote the velocity in the first medium as omega 1 by K1. How will you write the velocity in the second medium? You know how to write it? You wrote the velocity in the first medium like this. How will you write the velocity in the second medium? It's a very simple question. When it goes in the second medium, what changes?
Sir.
Hmm?
K changes.
What does not change?
Omega.
What is the formula of velocity in the second medium?
Omega 2 by
When it goes to the second medium, what changes?
K changes. And
What does
omega
not change?
omega.
What is the formula of velocity in the second medium?
Omega 1 by K2, sir.
Should it take rocket science to give me this answer? You've taken 2000 seconds to give me this answer. Should it have taken so much of time? No. So this is the velocity in the second medium. But you don't know the value of
K2.
K2. So what you have to do is to find out the value of
K2.
K2. How will I find the value of K2? This is a wave on a string. Did we read anything about the speed of wave on a string? Did we read anything about speed of wave on a string?
Sir.
Did we read anything about the speed of wave on a string? No, we did not read. We did not read this formula that velocity of wave on a string is given by the formula T by mu. We did not read this formula. I think so. Mu1 is the mass per unit length in the first medium. The speed of the wave in the second medium, because the tension is going to remain same, it will be given as T by mu2.
2. Yes, sir.
So what is the value of V2 in terms of V1? You can find out the value of V2 in terms of V1. What is V2 in terms of V1? Can you tell me? What is V2 in terms of V1? Can you tell me? It is given as the linear mass density of the second string is 4 times that of the first string. Can you tell me V2 in terms of V1? You can't tell
V1,
me. It's a simple
V1,
division.
sir, V1 is equal to half V2. Sorry, V2 is equal to half V1.
V2 is equal to half V1. That is the simplest possible thing that you have to do. Now I got the relation between V2 and V1. Can you now tell me the relation between K2 and K1? Can you now tell me the relation between K2 and K1 since you know the relation between V1 and V2?
K2 equal to 2K1, sir.
K2 is equal to 2K1, sir. Thank you, sir.
Yes, sir.
Now, since we know both V1 and V2 and everything, can you tell me the equation? Can you tell me the amplitude of the reflected wave?
Vector wave is V1 by V1 plus V2 into AI. V2 minus V1 by V1 plus
I
V2.
don't know the formula. You have to tell me the result. I know the formula.
V2.
It is V2 minus V1 upon V1 plus V2. I know it.
Minus,
Multiplied by AI. Yes.
minus 1 by 3, sir.
What does minus AI by 3 indicate? What does this negative sign indicate?
Direction. Sorry.
What does this negative sign indicate? What does this negative sign indicate?
Direction.
That the wave has undergone a phase reversal of pi. Just now I told you that. Can you now tell me the amplitude of the transmitted wave? It is 2 times V2 divided by V1 plus V2 times AI. Can you now tell me the transmitted wave ka amplitude? You can see it from here. One of the wave is AI by 3, so the other wave has to be. One wave has taken 1/3 of the amplitude. So what will be the other wave doing?
Right, sir.
And it will be positive. Positive and negative only tells us that the direction has reversed, that the phase has reversed. Now you have AR, you have AT, you have K2, you have V2. Can you tell me the equation of the transmitted and the reflected wave in terms of the original K1, W1 and AI? Can you tell me that? YR, what is the what is the what is the equation of the reflected wave, my dear friends? If you want to use negative, you can simply use negative here. AI by 3 cos of K1x plus omega 1t. Now you don't have to add pi because you have already done pi on the outside, minus sign on the outside. Do we understand this? So this has gone above our head saying bye bye sir, bahut ho gaya sir, please leave me sir.
We got it, sir.
Now you have the formula for
by
the
3
transmitted
AI
wave.
2
2
by
by
3
3 AI
cos
cos.
omega 1t
First you say you have to say kx, that is our wave. Wave is written, so you have to write it in the same wave. Yes.
2k1
2k1
plus
x
x plus plus
minus omega 1t.
sir,
It is still
minus
going.
omega 1t.
This was it. Was it so difficult for you that you could not do? You did not know how to start the question. Anyways, I leave it at that. I'll give you 2 minutes to note it down. And we move ahead. Don't worry, this question is not going to come in JEE Main. It is way above the level of JEE Main. To not come in JEE Main. Don't worry about that. Okay. Then we come to the next topic, the last topic for this chapter, but again we'll have to do the entire thing once again for longitudinal waves. Standing waves, khadi hui waves, standing waves. Standing or stationary waves. When do we have standing or stationary waves formed? Huh? When are standing waves formed? Stationary waves, standing waves. Yes, my dear friends. No idea? Huh? No one knows. Keep quiet. That is better. Keep quiet. That is better. We don't know, that is better. Ignorance is better than saying anything. Standing wave, my dear friends. Khadi hui wave, standing wave, traveling wave, right? Stationary wave. Are apply some common sense. The name of common sense is common sense, but it is very uncommon. So common sense should be called as uncommon sense. So what are standing waves, khadi hui waves? When two progressive waves, they could be longitudinal waves or transverse wave, but it cannot be one longitudinal and one transverse. That thing, nothing will happen. Having number one, same amplitude, dung dung dung. Number two, same time period frequency, dung dung dung. Wavelength, traveling with the same speed in the same medium, dung dung dung, along the same straight line, dung dung dung, but in opposite directions. Oops. Same amplitude, same A,
Answer first question, the first point.
same F, same omega, same T, same medium, same line, same straight line, but
in
in
direction.
opposite
Direction.
direction.
Yes, sir.
But in opposite direction, when they superimpose on each other, a new types of wave is formed, that is known as the standing wave or the stationary wave. Standing wave, khadi hui wave. Remember, these standing waves are possible only in a bounded medium. A medium which is bounded, it's not free. Wave cannot go from one medium to other medium, because if wave can go from one medium to other medium, the reflected wave will not be having the same amplitude. So it is only possible when the entire wave is getting reflected back. Do we understand this?
Yes,
Or it has
sir.
gone above our head saying bye bye sir, मैं जा रहा हूँ, बहुत हो गया. Enough for today. Let me have a rest. Huh?
Done, sir. 1 minute, sir.
Have you noted it down?
Happen now. Done, sir.
Okay, so these are standing waves. Now to understand standing waves, there could be different equations that may come across. Depending on the equations that are coming across, we can have different types, and that is all mathematical in nature. You can take one example, and from that example we can understand this standing wave. Suppose I have two waves, and these are the two waves that are given to me. The first wave is given to me as y is equal to a sine omega t minus kx. The second wave that is given to me is a sine omega t plus kx plus phi. And if I take this phi as 0, just for the sake of taking it, so that I don't have complications. If I take this phi as 0, so now these are representing two waves which are traveling in the same x-axis but in the opposite direction, having same amplitude, same frequency, same time period, and same amplitude. Now if I superpose these two waves, y, and I write this as y1 plus y2, it is a simple addition of sine A plus sine B. Yes or no? Huh?
Yes, sir.
Simple addition of sine A plus sine B. So tell me what will be the result that you will get. Tell me what is the result that you are going to get from here. I'll give you 2 minutes. This is simple test of your simple trigonometry. Simple test of your simple trigonometry. Simple test of your simple trigonometry. Yes, my dear friends. Sine A plus sine B.
Sine A cos B plus.
I don't know. You just tell me the answer. I don't remember those results, and I don't want to remember them. Yes, what will you get? We don't know, sir. We don't know what is sine A and sine B. Huh? Anyone got any answer? Tell me what is the answer, Jalli.
2A sine omega t
Okay, thank God. 2a sine omega t into
cos kx.
cos kx. That is correct. So I can now write it like this: 2a cos of kx times sine omega t. Yes or no?
Yes, sir.
This, my dear friends, boys and girls, ladies and gents, this is what we call as a sine, a standing wave, खड़ी हुई wave, stationary wave.
Yes, sir.
This is a stationary wave, my dear friend. Now, you can do certain kinds of thing, and I'll give you that fata, fata, sata, fat. Now remember, any wave, any wave must satisfy the wave equation, and you can see this is a simple sine wave. This is a simple sine wave. I've written in the form of a simple sine wave. Yes or no? It is a simple sine wave, and it represents a wave because it satisfies the wave equation, but it is not in the form of f of x or ax plus or minus t or x plus vt or whatever. It is not in that form, and therefore it cannot be called as a traveling wave, but it satisfies the wave equation, and hence it becomes a wave. But this is a stationary wave. Do we understand this? Or it
Yes.
has gone above our head saying bye bye. It satisfies this equation, therefore it is a wave, but it is not in the form of function of x and t, and therefore it is not a traveling wave. Do we understand this?
Yes, sir.
Yes or no? We understand this?
Yes, sir.
Hmm. 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 Is it making sense or are we talking nonsense?
It is
It,
making
it,
sense.
making sense. Okay, now remember this is just a sine wave. Now that was point number one that we have written. Point number one. Point number two is coming up on your screens. We now point number two, my dear friends. This is point number two. The amplitude of this wave. The amplitude of this wave is 2a cos kx. It does not vary with time, but it varies with position. So, depending on the position of the particle, basically what this equation is representing, this is representing equation of all the particles of the medium at all times. Do we understand this?
Yes, sir.
But now these particles, depending on their positions, they are still executing simple harmonic motion. Their angular velocity is still omega, but their amplitudes are not same. Do we understand this? Because their amplitude now depends on their position. We
Yes,
understand this, or this has gone above our saying bye bye, sir? Okay, done.
we understand.
Point number three. Are we ready for point number three? Point number three comes up. Huh?
Hmm?
The points where amplitude is minimum, in fact, amplitude is zero, are known as no. No. And after that, it is plain trigonometry. You can find the position of the node. And once you find the position of these nodes, you can understand, oops, you can understand what is the distance between two nodes. How much is the distance between two nodes? What is the distance between two nodes? Tell me. The distance between two nodes is? Huh?
Lambda by 4, sir. Hey, Kadu. Lambda by 2.
Thank God. Lambda by 2 is the distance between the two. See, universe is beautiful. We just have to be careful in this universe. 4% of which we see. Similarly, there will be a points. In stationary waves, nodes are equally spaced and the distance between the two nodes is lambda by 2. Don't forget this. Important point. Golden point. Do we understand this? Or this has gone above our head saying bye bye, sir. Ho gaya, sir. Leave it, sir. Enough, sir. We don't want to study anymore now, sir. Similarly, you will have points where the amplitude is maximum. In fact, amplitude becomes 2 times the original waves. 2a plus or minus 2a plus or minus 2a. Those are known as antinodes. You can find out their position by the equation of the wave. 2a cos kx should be equal to plus or minus 1. I mean, cos kx should be equal to plus or minus 1. Where does that happen? It happens on every multiple of pi. And therefore your distance between the antinodes also becomes how much?
Pi by 2.
Pi by 2. And therefore your distance between nodes and antinodes become pi by
Pi by
4. Do we understand this, or this has gone above our head saying bye bye, bye bye, bye bye? Nodes and antinodes, our new. And this will be the last point. If you understand standing waves, these are the most fascinating waves in the entire universe. The nodes divide the medium into segments or loops. All particles in a segment vibrate in the same phase, but in opposite phase in the adjacent segment. What do you mean by this? I will just draw a revolutionary diagram here. What revolution I am doing with the wrong color? I will draw this revolutionary diagram here. And this is how a standing wave is normally drawn. My revolutionary diagram is not looking good, so I will try to draw it again, and we'll take the discussion into the next class. Now this is one node, this is one node. Now a standing wave. Oops, my nodes are not equally spaced. So what I'll do is I will take this revolutionary diagram from somewhere. I'll take it down from somewhere and then present to you in a beautiful way. From where should I take down this diagram? Where is a stationary wave? This is good, but this will not help. Do I have a good diagram for a stationary wave? Do I have a good diagram for a stationary wave? Let me check it out. Let me check it out. Let me check it out. There are no good diagrams that I find for stationary wave. So I'll take this one. I'll take this one just to make a point. Now, this is how normally stationary waves are drawn. Now, why they are drawn in this way, we will discuss this diagram in the next class. So you can see some points here. These are nodes. Do you see this point nodes? N,
Yeah.
N, N, and then there are these blue points which are your
Antinodes.
antinodes. Now, why this wave is drawn like this? We will discuss this in the next class. Up till now, we have understood everything.
Yes, sir.
Yes or no? So we'll take it simply and slowly, and we'll try to make more sense of this nodes and antinodes in the next
Next
class.
class.
Okay, we understand this?
Yes, sir.
Okay, then we will continue this chart topic in the next class, and probably the next class we should be done with this stationary waves for transverse wave at least. I'll see you in the next class. Take care. Have a
Thank you,
good day.
sir.
Bye
Thank you,
bye.
sir.
God
Same
bless
to
you
you.
all.
Thank you, sir.
Bye.